Metalworking vices make it possible for manufacturers to get a grip on their work. A vise clamps and angles a metal blank so that computerized cutters can shape it into a precision part. You often see vices on how it's made, so let's find out how they are made. Holding steady is what vices are all about. These metalworking vices have parallel jaws that close tightly around a workpiece. Their firm grip means that parts for important things like aircraft or medical implants can be machined very accurately. To make a metalworking vise, they start with a steel rod. It spins in a lathe as tools carve threads into it. This transforms it into the lead screw for opening and closing the jaws of the vise. Next, cutters carve into an aluminum blank to turn it into a thumb screw for turning the lead screw. They give the outside of it a knurled texture for better gripping. The final tool shaves the rough-edged rim to make it smoother to the touch. This completes the thumb screw. An automated saw now cuts a steel bar into smaller pieces. Each one will be used to make the base of a vise. A cutter sculpts the outside of a base piece to give it the desired profile. Another cutting tool then moves through the center of the piece repeatedly to carve a channel. In addition to the base, the milling machine also creates components for the vice's shuttle system. The next machine tackles the reverse side of the vise base. It cuts it flat and smooth. It also machines holes for locating and mounting the completed vise to milling equipment. A constant flow of coolant protects the tooling from wear. They now lock a steel block in a vise, because yes, they do use vices to make some parts of vices. The vise holds the piece of steel firmly in place as tools shape it into one of two jaws. After heat treatment, it's into a blast chamber to spray small particles of very fine sand onto the jaw part. The sandblasting removes scale and blemishes. A worker now submerges all the parts of the vise in a hot chemical solution and leaves them there for 8 hours. The chemical solution gives the parts a black oxide finish that will protect them from rust. Here is the vise base before and after the oxide treatment. Next, a laser etches information onto the vise base, including the brand name, the part number, and the basic dimensions. A probe then gauges the size of the mounting holes, and it also determines if they've been drilled in the correct location. With that, it's time to assemble all the parts of the metalworking vise. The worker screws retainer rings onto the lead screw and then installs the screw in the base. He threads the shuttle devices onto the ends of the lead screw. He inserts spacing blocks in the channel. He moves the shuttle devices forward, using the spacing blocks as guides for the correct positioning. After removing the spacing blocks, he adjusts the retainer rings. He positions the steel jaws on the shuttle devices and bolts them in place. And once the thumb screw has been attached to the lead screw, the assembly is complete. Now it's over to a computerized measuring station. The controller positions the vise in the equipment, and then a probe moves in. It compares the coordinates of the vise to that of a computer model and confirms that it measures up to standards. 4 weeks in the making, these metalworking vices should hold up for many years.